In this lecture, I'll discuss the Poisson discrete probability distribution. This distribution is discussed in Mendenhall in section 4.10. The Poisson distribution is used to compute the probability of events that occur in some time interval or a region in space. For example, if you want to find the probability of so many traffic accidents happening over a certain weekend, that would be a Poisson distribution. If you're looking at defects in something that's manufactured over a certain region, that would be the Poisson distribution. To use this distribution, you have to know the average number of events that happen in that time frame or in that region in space. And the symbol for that is the Greek lambda. It's also called the mean because it's an average. So if you knew the average number of accidents that happen over Memorial Day weekend was, 67 events, traffic accidents happen over that weekend, that would be the number. Lambda would be 67. If you had that square sheet of plastic that you're manufacturing and you usually get 1.5 defects in 3 square yards, then lambda would be equal to 1.5. And there's a formula that's very easy to use for the Poisson distribution. This would be the probability that y, a discrete random variable that follows a Poisson distribution with an average value with a lambda of specified, is equal to, let me write it out. So I'm going to write it here a little bit and talk about the various terms. Here's E, Euler's number, to the minus lambda. Okay, multiplying lambda raised to the value y divided by y factorial. Now all that can be done, of course, on your calculator. You have to remember to use the parentheses and to get that negative lambda. It's not a very hard formula to do it all, but in the homework I think I just gave you questions that involved using R, and I'll show you how to use R in a minute. So here is the formula for the Poisson distribution, and this is a typical graph. And, in this example, lambda was 10.96. That was the average number of houses sold in one day by a realtor. And this is your Poisson probability distribution. Again, this y-axis, this is the probability. And if you knew the average was 10.96, what's the value at 10.96? Is it 1 because that's your average? No. It's in this case it's 0.12. All right. Remember that all of these have to add up to 1. Okay. It looks a little bit bell-shaped. You can see though that there's some difference here on the tails. Here are a few examples. Say you knew the average number of houses you sold in one day was 6, and you want to know the probability that tomorrow you're going to sell 10. Alright, so this is a probability that you will sell 10 in a Poisson distribution with a lambda of 6. And it's e raised to the 6th times 6 to the 10th divided by 10 factorial, and you've got about 4% chance of doing that. What if you sold a whole bunch of houses? Say in 1 year you sold 4,000 houses. What's the probability that 8 houses will be sold tomorrow? The reason for doing this is units. Alright, this problem you're concerned with, you want to know if you can sell 8 houses in 1 day, but your data has been given over a year. So you have to get the average for the day, so you have to divide by 365, and you find that it's 10, you sold about 11 houses a day. Alright, to sell 4,000 in the year. So I'm just trying to point out units here. The probability that you will sell 8 houses tomorrow when you typically sell 10.96 houses in a day, e to the negative 10.96 times 10.96 raised to the 8th over 8 factorial. right? Some of these seem like really small numbers. This seems like a really big number, and then it's divided by a large number. It works out. In this case, it's about 10% chance of selling 8 houses um, in one day. Remember that 0 factorial is 1. You can find the probability that 0 houses will be sold. In this case, it's very small, but you can still do the calculation. Finding at least or at most cases is done in the same way that it was done for the binomial distribution. You can either add up all the cases or you can add and subtract from 1. All right. Let's say you want to sell at most 3 houses. Okay, that's what you want to find the answer to, the probability of that. Then you have to compute the probability for selling 0, 1, 2, and 3. That's at most 3 houses. You have to add up all those probabilities, and each one is its own probability, Poisson distribution. You add up all those numbers. In this case, you got about 0.5% chance of selling at most 3 houses. Sometimes, especially for the at least case, it's easier to subtract from 1. Let's say you want to sell at least 4 houses. Well, that means you want to sell 4, 5, 6, and you don't care how many other houses you sell, as long as it's at least 4 houses. Maybe you have to make some kind of payment tomorrow. I don't know. All right. So that means you want to sell more than the 0, 1, 2, and 3 houses. What you can do to get greater than or equal to 4 is find the probability of less than and subtract that from 1. So here's the probability of selling the 0, 1, 2, 3, or 3 houses. Subtract that from 1, because remember, all the probabilities have to add to 1, and there's your answer, about 99% chance of selling at least 4 houses. Now let's go to R, and I'll show you how to do the problems again using R. Okay, so here I am using R, and so we're looking at the Poisson distribution, and I want to be able to find values for some exact number, or for at least, or at most, some random variable. Okay, what we're going to use is the distribution POIS. Let me write that out here on the screen. Not 2 S's, just 1. Obviously, that was a voice of experience telling you about that. It's going to have a prefix. The prefix is going to be a D. Sometimes when you want one particular value, it's going to be a P, like this, when you want at least, say at least 4 houses, or at most 4 houses. If you get lost in R, of course there's the tutorials, which are kind of focused on what we're doing here. You can also go like this. Help, and then put, and what? What I just showed you, you can't really see very well. Let me try to shrink it down into some kind of space. At any rate, it will go and open your browser and will give you a whole workup on, there we go. It will give you a whole listing of the distribution here. You can see it. That's going to talk about the Poisson distribution. This opens in your browser, okay? And it talks about the different forms of it, D, POIS, P, POIS, and the different parameters that it takes. This is not really a beginning discussion of it. It's just a sum of the commands. It talks a little bit about them, and then at the end it will give an example. Sometimes these examples are useful, and if you know it and you just need a review, this is pretty good. It's not exactly a good way to learn, though. Okay, I just wanted to point that out. Now let's say we want to find the Poisson distribution. We want to find the probability that you're going to sell, say you want to sell 7 houses tomorrow, and usually you sell, I don't know, 8.5 in a day. Let's see what that is. Sometimes you don't have to write the lambda equals. Some people will write these commands and just put the numbers in order. I think it's a very dangerous thing to do. It's better to label stuff. Okay, right now I'm not labeling this. I'm not giving it a value because all I want to do is see the answer, and when I hit enter I get the answer. So 12.9% chance of selling 7 houses tomorrow when I usually sell 8.5. If you want to use that number for something else, you can give it a name. Answer. Well, let's say I want to sell 9. And I usually sell 8.5. Whoops. Okay, when I do it like that, remember it doesn't give it to me right away. It stored it in the variable ANS that I gave it, the answer variable. And if I want to see its value, I type that and I get the same number back. Oh, no, a little bit different because I want to sell 9 houses. All right, 2 ways to do that. Now let's look at least or less than. And the parameter we have to work with now is going to be lower tail. If lower tail is true, which is the default, it will give you all the values less than a certain value. If you set lower tail equal to false, it will give you the other case. And instead of using D, which gives me just one number off the distribution, I have to use P. So I want to go, I'm not going to give it a name, I'll just go, whoops, I need 2 of them. Alright, I want to know if it's possible to sell at least, say, 7 houses. That means I would have to, if I do this by hand, find the probability for 0, 1, 2, 3, 4, 5, 6 and add them up. It's going to do it automatically. I specify my lambda and I get the answer. It's about 40% chance that I will sell at least. Now if I want to sell, oh no, I'm sorry, that's at most. Oh my goodness, excuse me for saying that wrong. Okay, all right, in this case I took the default, which is lower tail equals true, and I got at most because I got everything less than 7. Now I'm going to repeat the calculation here and do, I can recycle it by going up like that, go in here, put a comma, lower dot tail equals, whoops, equals false. And this is what I get. This would be at least 7 houses. So 7, 8, 9, 10, infinite number of houses. That's the probability of selling at least 7 houses. Notice they add up to 1 as they should.